Okay, we're going to be looking at the reproductive cycle in females, and that's a repeating set of events in the ovaries and the uterus that results in the ovulation of a haploid egg and preparation of the uterus for the possibility of a pregnancy. So females will ovulate 400 to 500 times across their 40-year reproductive lifespan, and there's always the possibility with each ovulation that they are sexually active and could potentially get pregnant. So the average duration of the reproductive cycle in females is 28 days, and we're going to use that as our average duration as we talk about it. And the reproductive cycle actually consists of two separate cycles that occur at the same time but in different locations. So one occurs in the ovary, the other in the uterus. So the ovarian cycle is one of the two cycles. It occurs in the ovary, and it involves the ovulation of a haploid egg from the ovary that then goes into the fallopian tube, and the secretion of the ovarian sex steroid hormones, estrogen and progesterone. The other cycle is known as the menstrual cycle, and that refers to changes that occur within the endometrium or lining of the uterus. And these endometrial changes help to prepare the uterus for, again, the possibility that a pregnancy results and an embryo needs to implant into the uterine wall and then go through a 9-month pregnancy. So we're going to just combine the ovarian cycle and the menstrual cycle events together, and I'm going to refer to all of the events that occur in the ovary and the uterus as the menstrual cycle. And as we look at the menstrual cycle, ultimately I'll break it down into 4 phases: menses, the pre-ovulatory phase, ovulation, which is more of an event than a phase, and the post-ovulatory phase. So we'll start with just a short look at puberty. And puberty is a multi-year period of time when the body of both girls and guys goes through a number of sex-specific changes. These are real noticeable changes that occur between the ages of 10 to 12. Some can start puberty as early as 8. In some cases, puberty is delayed until a kid is 14, 15, even 16 years old. But in general, it happens during the middle school years. So in females, the changes include the formation of what are known as breast buds, and that just means the breasts are starting to enlarge. Pubic hair starts to form, as well as hair in the armpit region. Menstrual cycles begin. So puberty in females ends when she ovulates an egg and has her first period. Once she's had her first period, puberty's over, and she becomes a post-pubescent. There are 2 hormones from the pituitary gland that we talked about in the male. They are the gonadotropins, secreted from the anterior pituitary, FSH and LH. FSH and LH are peptide hormones made of amino acids. They're secreted from the anterior pituitary into the blood, and the blood then carries them to the ovaries, where they have effects in females. Of course, they have effects in males as well. So it turns out that these 2 hormones were discovered first in females and given the name FSH for follicle stimulating hormone and LH for luteinizing hormone. So these names, because they were discovered first in females, make sense, only in the female. The hormones were subsequently discovered in males and called FSH and LH. They retain the name, but really the meaning of FSH and LH doesn't apply to the guys, but the meaning of FSH and LH does make sense in the female reproductive tract. So, FSH, or follicle stimulating hormone, from the anterior part of the pituitary gland, stimulates an ovarian follicle in the right or the left ovary to develop. And as it develops, it secretes the ovarian follicle increasing amounts of a steroid hormone called estrogen. So LH is what's known as a luteinizing hormone, and it triggers an event that occurs at the midpoint of a 28-day cycle called ovulation. And ovulation is when the ovarian follicle ruptures and releases the egg onto the surface of the ovary. Once ovulation occurs, that haploid egg goes into the fallopian tube, where it may or may not be fertilized by a sperm. So, ovulation, as we'll see, is a fairly quick event that only takes maybe 2 or 3 minutes. And once ovulation occurs, the ovarian follicle without the egg in it, because the egg's been ovulated, is now called the corpus luteum. And we'll take a look at this in more detail later. So let me just show you kind of a graphic of what's known as ovulation. Ovulation is the release of a haploid egg from the ovarian follicle. And recall that the ovarian follicles form in the cortical region, or outer region of the ovary. And this is going to be an ovarian follicle, actually one that's fully developed. And what's going to happen is somewhere around the midpoint of the menstrual cycle, or day 14, there's going to be a surge of the gonadotropin LH, and it's going to cause the ovarian follicle to split open or rupture. And when it does, the egg is released onto the surface of the ovary. And then after ovulation occurs, the egg enters into the fimbriated end of the oviduct. So, the ovarian follicle will rupture or split open and release its egg onto the surface of the ovary. And the ovarian follicle cells without the egg inside are now called the corpus luteum. We're going to look at this in more detail later. Just wanted to kind of give you a sense of what ovulation means and the conversion at ovulation of the ovarian follicle to the corpus luteum. The ovaries make two important steroid hormones. Because the source is the female gonad, they're referred to as the sex steroids in the girls. The sex steroid in guys from the Leydig cells of the testis would be testosterone. So steroid hormones, as we talked about, are synthesized from cholesterol. And just before we go on talking about estrogen, let me just mention one more time, because I know I said it earlier, that estrogen is not technically a hormone. It honestly refers to a group of 3 hormones that are the estrogenic hormones, and that's estradiol, estrone, and estriol. So, I'm going to just say estrogen, as if estrogen is a hormone. Everybody does that, and we'll never revisit estradiol, estrone, and estriol, the 3 forms that estrogen takes. Recall that testosterone from the Leydig cells of the testes is responsible for the phenotypic look of guys. The bigger muscle mass, the greater battle with acne, and some of the other changes that we talked about. Estrogen, on the other hand, in females is the feminizing hormone, which is responsible for the phenotypic look of females. So the difference in the look between guys and girls is a difference created by the masculinizing hormone testosterone in guys and the feminizing hormone estrogen in the females. We're going to find that estrogen is secreted by two structures in the ovaries, the ovarian follicle as well as the corpus luteum. So let's talk about some of the effects that estrogen has on the female body. So during each menstrual cycle, estrogen is released from the ovary, and it will stimulate early on in the menstrual cycle the mitotic division of the cells of the stratum basale, or basal layer of the endometrium, to grow. And the basal cells, when stimulated by estrogen, grow out to form the stratum functionalis layer. This is referred to as the thickening of the endometrium, and as we'll see, it takes about 9 days to thicken up. Estrogen, in addition, will cause the coxal bones of the hip to get wider, and as a result, females have wider hips as compared to males. Estrogen will stimulate the deposition of fat molecules or triglycerides in adipocytes beneath the skin. This is particularly true in the breast, hips, and thighs, and contributes to the hourglass look of females. Another effect of estrogen is to stimulate cells associated with bones called osteoblasts. So osteo means bone, blast means to form. These are bone-forming cells. And when stimulated, osteoblast will increase the density of calcium salts in the bony matrix. An increase in the density of calcium salts in the bony matrix makes the bone itself harder and stronger. Stronger bones are less likely to break or fracture. Another effect of estrogen is to stimulate closure of the epiphyseal or growth plates of bones. So I've drawn a picture of a long bone, and these would be the expanded ends or the epiphyses, and between them is the shaft or diaphysis. These growth plates during the growth years occur between the epiphysis and the diaphysis, and they're referred to as epiphyseal plates. So we looked in detail at the function of the epiphyseal plates with bone elongation in AMP1. So if you need to kind of refresh on that, then I'd encourage you to do so. So estrogen will stimulate the closure of the epiphyseal plates, and as a result of the estrogen secreted by ovaries in females, the epiphyseal plates close earlier in females as compared to guys. Once an epiphyseal plate closes, all of the hyaline cartilage associated with the epiphyseal plate has converted to bone, and as a result, the bone can't get any longer. And this certainly would be true of the long bones found in the upper and lower extremities. A female has reached her adult height. So, the female who starts menstrual cycles in the 7th grade and her ovaries begin to secrete estrogen, because of this estrogenic effect on closing the epiphyseal plates and stopping the further elongation of bone, within about 3 years, or by the 10th grade, that female will have reached her adult height. So if you're a basketball or a volleyball coach and you want really tall girls, you can look out at your 10th graders and just know that probably not going to get any taller. Guys, on the other hand, without this estrogenic effect, have growth plates that persist for several years longer, into the late teen years. And as a result, the average height of females with epiphyseal plates that tend to close somewhere around the 10th grade, when a girl is 15 or 16, is 5 foot 4 inches. Whereas the epiphyseal plates of guys stay active for a few more years, and as a result their bones elongate even more so, and the average height of males in the United States is 5 foot 9 inches. So a guy playing basketball as a 10th grader is likely to continue to get taller all the way through into his senior year. Progesterone is the other sex steroid derived from cholesterol that is secreted by ovarian cells. Progesterone is known as the hormone of pregnancy because progesterone is essential for maintaining a successful pregnancy. In fact, if you block progesterone's effects during pregnancy, particularly early in pregnancy with what's called the abortion pill as a source of mifepristone, then you'll terminate the pregnancy. So progesterone is not secreted by the ovarian follicle. Instead, it is secreted after ovulation by the cells of the corpus luteum. So a couple of the progesterone effects, we'll take a look at those in just a second, but progesterone is important because it helps to prepare the uterus for the possibility of a pregnancy. So a female ovulates each menstrual cycle, and a female typically has over 400 menstrual cycles across her reproductive lifespan, from say 12 to menopause that occurs around the age of 52. And that means the uterus, with every ovulation, has to prepare for the possibility that fertilization might result in an embryo that will implant 7 or so days after fertilization. And progesterone helps to prepare the uterus for the possibility of a pregnancy. So some of progesterone's effects include the stimulation of glandular epithelial cells in the endometrium to secrete nutrients. And these are nutrients that nourish the developing embryo. It takes a little while for the developing embryo to develop an umbilical cord, and certainly in the early stages of pregnancy, these nutrients prior to the formation of an umbilical cord are essential for maintaining the health of the embryonic cells. Progesterone also has what's known as a quieting effect on the myometrium, or the middle layer and thickest layer of the uterus. So progesterone during a pregnancy will inhibit the contraction of the smooth muscle cells that make up the bulk of the myometrium. You don't want those cells contracting during pregnancy because they create shear forces that might dislodge the embryo from the uterine lining, and if that occurs, it would terminate the pregnancy. So we're going to take a look at the menstrual cycle, and as we do, we'll take a look at menses, when a girl is having her period. That's a 4 or 5 day stretch where girls would be using a tampon that they insert into the vagina in order to absorb what's known as the menstrual discharge. The menses phase leads to the pre-ovulatory phase, events that occur before ovulation. And then ovulation occurs, and then there are events after ovulation, referred to as the post-ovulatory phase. So we're going to assume, again, a 28-day cycle, which is the average duration of menstrual cycles among females. Although that can vary. It can be shorter than that, it can be longer than that. But we're going to assume a 28-day cycle where ovulation occurs on day 14. So 28 divided by 2 is 14, which means that day 14 would be the midpoint of this 28-day cycle. So menses, when a girl is having her period, lasts about 5 days. So it would go from day 1 to day 5. During menses, the functional layer of the endometrium dies and sloughs off into the uterine cavity. I'll draw pictures of this later. As the cells of the stratum functionalis die and fall off, blood vessels within the endometrium break and blood spills into the uterine cavity and mixes with the dead endometrial cells. And this forms the bloody discharge. So the bloody discharge is the sloughing off of the dying and dead functional layer cells into the uterine cavity and the breakage of blood vessels in the endometrium that mixes with these dead endometrial cells to form this discharge that then would go from the uterine cavity down into the vagina. So, menses, or a period, is a sign that a female is not pregnant. So, the contents of the menstrual discharge include dead endometrial cells. These are cells of the functional layer that die and slough off. And recall that I said earlier that the basal cells don't get shed. They're always retained because the basal cells are what regrow the functional layer with each repeating menstrual cycle. So in addition to the dead endometrial cells of the functional layer, over a 5-day period, there's about 30 to 40 mils or so of blood. And the endometrial cells during menses secrete an anticoagulant called heparin. Heparin mixes with the blood in the menstrual discharge and prevents it from clotting. So the blood stays very fluid, more so than you'd expect, and that helps the menstrual discharge with the blood flow out of the uterus and into the vagina where it would be absorbed by a tampon. The hormone levels during menses are essentially very, very, very low because during menses there aren't any active hormone producing structures in the ovary. There aren't any active ovarian follicles or any active corpus luteum, and as a result the ovary during menses is not secreting estrogen and progesterone. After the bloody discharge phase, where the endometrial lining is sloughing off and the menstrual discharge is forming and moving out of the uterus to the vagina, once the functional layer of the endometrium has completely sloughed off all the way down to the stratum basale, the pre-ovulatory phase begins. And these are events that occur after menses but before ovulation. So the pre-ovulatory phase lasts for around 9 days. So if menses goes from day 1 through day 5, and this lasts for 9 days, this would go from day 6 to day 14, which is the midpoint of the cycle where ovulation occurs. So the pre-ovulatory phase begins as follicle-stimulating hormone, or FSH, is secreted from the anterior pituitary. And FSH from the anterior pituitary travels by way of the blood to the ovary, where it will stimulate an ovarian follicle in the right or the left ovary to develop. The development process means that the follicle cells are going to divide by mitosis and increase in number or proliferate. So most of the time, only one ovarian follicle is stimulated by FSH in either the right or the left ovary. And that can vary from one menstrual cycle to another. Maybe the right this menstrual cycle, maybe the right again, then the right, maybe then the left, right, left, left. Anyway, you get the idea. But occasionally, FSH will stimulate more than one ovarian follicle, maybe 2 or 3. And in that case, 2 or 3 eggs can be ovulated. And if both or all 3 were fertilized, it might result in twins or triplets. So as the ovarian follicle that's stimulated by FSH develops during the pre-ovulatory phase, the number of follicle cells associated with the stimulated ovarian follicle increase in number. Now, as the follicle develops, the follicle cells start to secrete estrogen in increasing amounts. So if 10 or 20 ovarian follicle cells secrete this amount of estrogen, as the number of follicle cells increases, so does the amount of estrogen secreted over time by the ovarian follicle. The estrogen that's secreted by the ovarian follicle as it develops over a 9-day pre-ovulatory phase will stimulate the basal cells of the endometrium to divide by mitosis and grow out a functional layer. This causes the endometrium to thicken, and it literally will go from a pencil-thin stratum basale thickness to maybe a 1/4 inch in thickness once the functional layer fully forms. At the end of the pre-ovulatory phase is a surge-like release from the anterior pituitary of LH. And that surge-like release of LH, that means a lot of LH is being released, will trigger ovulation. So before we talk about ovulation, let me just go over some of the events that occur during the pre-ovulatory phase, which lasts about 9 days. So at the beginning of the pre-ovulatory phase, in other words at the end of menses, when the pre-ovulatory phase begins, FSH is secreted from the anterior pituitary, and it stimulates one of the many follicles found in the cortex of the ovary to develop. So let's say FSH stimulates this ovarian follicle to develop. As the follicle develops over the 9 days of the pre-ovulatory phase, the follicle cells start to divide by mitosis and increase in number. So again, if 20 follicle cells secrete this much estrogen, as the number of follicle cells increases, then the greater number of follicle cells secrete increasing amounts of estrogen. So we're going to find that estrogen levels will go up and up and up across this 9-day pre-ovulatory phase. And one of the estrogen effects during the pre-ovulatory phase is to stimulate the thickening of the endometrium. So this would be an egg surrounded by a single layer of follicle cells. And by the end of the pre-ovulatory phase, the ovarian follicle is much larger, and it sort of emerges as a bump-like structure on the surface of the ovary. And as the follicle develops, the follicle cells spread apart and create a fluid-filled cavity in the middle of the ovarian follicle in which the egg floats. So just to reiterate, the cells of the ovarian follicle as they develop secrete increasing amounts of estrogen. And this is how the follicle looks at the end of the preovulatory phase, before ovulation occurs. Okay, so we'll talk just a little bit about ovulation. Ovulation is an really short event in that it only takes 2 to 3 minutes. So we don't say it takes up a whole day. It's just an event that occurs in 2 or 3 minutes on day 14, which is the midpoint of our 28-day cycle. Ovulation is the release of the haploid egg from the ovarian follicle of the ovary. And it's stimulated by a surge-like release of LH, known as the LH surge. And the source of LH would be the anterior part of the pituitary gland, or the anterior pituitary. So this LH surge, or surge-like release of LH from the pituitary gland, begins about 36 hours before ovulation occurs. And then the LH levels just increase in the bloodstream, and at some point in time, ovulation occurs in response to this increasing surge-like release of LH. So, we're going to find that intercourse must occur around the time of ovulation if a female is going to get pregnant. A woman is fertile each menstrual cycle, and fertile means capable of getting pregnant, for maybe around 5 days. The reason for that is the ovulated egg only lives for 12 to 24 hours in the fallopian tube. And 12 to 24 hours after ovulation, the egg, if it's not fertilized, simply dies. Sperm, however, can live in the female reproductive tract for up to 5 days. So a couple could have intercourse several days before ovulation, and a guy ejaculates sperm-containing semen into the vagina. Within 30 minutes or so, the sperm cells have swum from the vagina into the uterus, and from there up into the fallopian tubes. And sperm cells can live in the fallopian tubes for several days. So sperm ejaculated into a female's body several days before ovulation can still fertilize that egg. And that's why, despite the fact that the egg itself only lives for 24 hours, there's a window of time that's probably 4 or 5 days wide in which a female can get pregnant, primarily because the lifespan of sperm in the female reproductive tract. So sperm, once they've been ejaculated, swim at about 1 foot per hour, and so they literally are going to get up into the fallopian tube within 1 hour after ejaculation. And again, they can live in the fallopian tube for several days. So, just a little bit about ovulation before we move on. Ovulation is the release of the egg from the ovarian follicle. So, here's the ovarian follicle, and the follicle cells secrete estrogen. And then at the end of the preovulatory phase, there's this surge-like release of LH from the anterior pituitary, known as the LH surge. And the LH surge causes the ovarian follicle to rupture or split open. And when the ovarian follicle splits open, an egg is released, and after ovulation, that egg then can go into the fallopian tube where fertilization may or may not occur. The ovarian follicle, once the egg has moved out of it, is no longer called an ovarian follicle. The ovarian follicle without its egg is still in the ovary, but now it's called the corpus luteum. And the cells of the corpus luteum the ovarian follicle without the egg, secrete not only estrogen but progesterone for the first time. So this would be an ovarian follicle with an egg inside, and the LH surge causes the follicle to split open, and when that occurs, the egg goes out through that opening onto the surface of the ovary. And this event here is ovulation. Once on the surface of the ovary, the egg can be drawn into the fimbriated end of the oviduct of the fallopian tube, and that's facilitated by the beating of the ciliated cells that line the fimbriated end of the fallopian tube. The corpus luteum is the ovarian follicle that has lost its egg to ovulation. Once ovulation occurs, and again it only takes a couple minutes, the female enters into what's called the post-ovulatory phase. And this is a phase that lasts for 14 days. So, the post-ovulatory phase begins at ovulation, which occurs on day 14, and then continues for 14 days, which would take us to the end of our 28-day cycle, or day 28. But during the post-ovulatory phase, the endometrium has to prepare for the possibility an embryo formed and will implant. And the embryo implants around 7 days after fertilization. Now during the post-ovulatory phase, let me just back up. During the pre-ovulatory phase, it's the ovarian follicle that's active, secreting estrogen. And during the post-ovulatory phase, the active ovarian structure is the corpus luteum, secreting not only estrogen, but for the first time, progesterone as well. Then we're going to find that during the post-ovulatory phase, estrogen works with progesterone to maintain the health of the endometrial cells so that the functional cells won't die and slough off. And progesterone will stimulate glandular epithelial cells in the endometrium during the post-ovulatory phase to secrete nutrients that the embryonic cells need. So, we're going to continue talking about the post-ovulatory phase. If a pregnancy doesn't occur, that means there wasn't a fertilization event and an embryo that formed. So if a pregnancy does not occur, then the cells of the corpus luteum are genetically programmed to die within 12 to 14 days. That's their lifespan if a pregnancy does not occur. Now when the corpus luteum, when the cells of the corpus luteum die, they no longer secrete estrogen and progesterone, and estrogen and progesterone levels in the blood would plummet. I mean, they drop sharply within a very short period of time. And without estrogen and progesterone from the corpus luteum that has died at the end of the post-ovulatory phase, the cells of the stratum functionalis of the endometrium can no longer be maintained, and they start to die. And as they start to die, they slough off of the wall of the uterus into the uterine cavity. Blood vessels break, the dead endometrial cells mix with the blood, some heparin is secreted, and that's the menstrual discharge. So once the estrogen and progesterone levels drop precipitously as the corpus luteum dies at the end of the post-ovulatory phase, the menstrual discharge begins to form, and we go to menses at the beginning of the next menstrual cycle. So just a little bit more about the post-ovulatory phase. There's always the possibility that a woman is sexually active, a guy ejaculated semen into the vagina, The sperm cells made it up into the fallopian tube and fertilized an ovulated egg. And that's a woman who is going to get, she's pregnant. So fertilization of the egg by the sperm has to occur in the oviduct within 24 hours of ovulation. And that's because the ovulated egg only lives up to 24 hours in the fallopian tube. And if it's not fertilized within 24 hours of ovulation, the egg dies. So, after fertilization, the zygote that forms in the fallopian tube divides by mitosis into an embryo. And the embryonic cells increase in number across a 3 to 4 day stretch as the embryo moves down the fallopian tube into the uterine cavity, where it remains for another 3 to 4 days before it implants into the endometrium. So implantation of the growing embryo occurs around 7 days or so after fertilization. Now, the embryo and the baby that forms in the uterus over a 9-month pregnancy has a parasitic relationship with the mother. The embryo and the fetus that develops from the embryo take from mom's body, but essentially give nothing back in return. So not surprisingly, the embryo has to protect itself, as a parasite. And after implantation of the embryo into the endometrium, the embryonic cells secrete a peptide hormone called human chorionic gonadotropin. That's HCG. So you don't have to know this human chorionic gonadotropin, but know that the embryonic cells after implantation secrete a hormone called HCG. And the HCG secreted by the embryonic cells goes into mom's blood, and mom's blood then would carry the HCG to the ovary, where the HCG prevents the corpus luteum that would otherwise be programmed to die after 14 days to not die. So HCG is a hormone secreted by embryonic cells after implantation that prevents the corpus luteum from dying. And as a result, the corpus luteum stays active and continues to secrete estrogen and progesterone, which maintains the health of the endometrial cells so that they don't die and slough off, because if that occurred, the endometrium, as it sloughed off, would carry the implanted embryo with it, and all that would just flush out of the uterus and abort that pregnancy. But that's not what happens. So there is an inexpensive test that one can buy at a CVS or on, from Amazon.com or a pharmacy or probably a grocery store, called a pregnancy detection test. And it's something that you can buy without a prescription. And it's something that a female would buy if she was having unprotected sex and skips a period or skips menses. So she knows that she's had unprotected sex and a guy has ejaculated semen into her body, and she skips a period or doesn't have menses, which means the corpus luteum is active because it's being stimulated by HCG and continues to secrete estrogen and progesterone, so the endometrium doesn't slough off. In other words, menses doesn't occur. And she's going to take this test to see if she is pregnant. So it turns out that the HCG secreted by the embryonic cells to prevent the corpus luteum from dying gets filtered from mom's blood by the kidney and ends up in the urine. So pregnancy detection test looks for HCG in the urine, and if HCG is in the urine, in other words, a positive pregnancy detection test, then the HCG would be coming from the implanted embryonic cells, and the female would be pregnant. So, let me just talk a little bit about birth control pills. Birth control pill is sometimes called an oral contraceptive. So, oral means you're going to take the pill by swallowing it. Contra means against, and inception means to create. So, a contraceptive is some kind of drug that prevents a pregnancy. So a birth control pill is generally what's known as a combination pill that contains both estrogen and progesterone. And birth control pills prevent the release of LH from the anterior pituitary. And by preventing the release of LH, they block ovulation. So a female taking birth control pills should not ovulate an egg. And if an egg is not ovulated, then a fertilization can't occur, and as a result, the female can't get pregnant. And birth control pills are very effective if taken on a regular basis without skipping pills. So another form of birth control is what's known as a copper IUD, where IUD stands for intrauterine device. And a copper IDD is a very small T-shaped device, maybe about the size of a quarter, that's inserted into the uterus by a physician. The copper part of the copper IUD is a copper wire that's kind of coiled around it, and copper is toxic to sperm and egg. And as a result of the toxicity of the copper wire associated with a copper IUD, sperm and egg aren't viable, and fertilization does not occur. The result, of course, is no pregnancy. The IUD that's inserted can be removed at any time if the female decides that she wants to get pregnant. And the copper IUD is highly effective, like over 99%, preventing a pregnancy, and it can prevent pregnancies for up to 10 years and maybe even as long as 12 years. There is a pill that females can take to abort a pregnancy. It contains a drug called mifepristone, occasionally called RU-486. This obviously is a prescription drug that, when taken, will abort an embryo in the first 8 weeks of pregnancy. And mifepristone, the active ingredients in the abortion pill, blocks the effects of progesterone. Progesterone is the hormone of pregnancy, and its effects are critical to maintaining a pregnancy. So this is an anti-progestin, or a drug that blocks the effects of progesterone, and that in turn will terminate a pregnancy. And lastly, the morning after pill, which is available at pharmacies without a prescription. And the morning after pill contains high levels of progesterone that, when taken, will prevent ovulation. So a female who's had unprotected sex, a little bit scared that maybe she is going to ovulate and possibly get pregnant with the sperm that was introduced into her body, might the next day or the morning after she's had sex go and buy the morning after pill and take it to prevent ovulation. So I did want to finish up by looking at a graph of hormonal changes that occur in a female's body during each menstrual cycle, and tie these changes to the thickness of the endometrium and changes that occur within the ovary as the ovarian follicle develops, ovulation occurs, the corpus luteum forms, the corpus luteum dies, etc. So, day 1 through day 5 would be menses. And that's the bloody discharge phase. So let's assume that the line all the way here at the bottom is the stratum basale, because it's a fairly thin layer. And then above it, all this would represent the stratum functionalis, layer of the endometrium. So what happens during menses is that the cells of the stratum functionalis die and slough off. So the endometrium thins all the way down to the stratum basale during the 5 days of menses. Now towards the end of menses, in the beginning of the preovulatory phase, FSH is released from the anterior pituitary, and FSH at the beginning of the preovulatory phase will stimulate an ovarian follicle in the right or left ovary to develop. And that means the follicle cells around the egg will divide by mitosis and increase in number. And as these follicle cells increase in number, they release increasing amounts of estrogen. So if we track estrogen, there's no estrogen being secreted during menses. But as the ovarian follicle starts to develop, there is increasing amounts of estrogen being secreted from the developing ovarian follicle. And the estrogen that's being secreted from the developing ovarian follicle stimulates the basal cells of the endometrium to grow a functional layer, and the endometrium gets thicker and thicker and thicker, reaching pretty much its maximal thickness towards the midpoint of the menstrual cycle. So, at the end of the pre-ovulatory phase, somewhere around day 13, the anterior pituitary starts to secrete increasing amounts of LH. And this is referred to as the LH surge. The LH surge will cause ovulation. The LH surge causes the ovarian follicle to split open, and the egg is released onto the surface of the ovary. And this event is called ovulation. The ovarian follicle without the egg is now called the corpus luteum. So the corpus luteum forms at ovulation. The cells of the ovarian follicle secrete estrogen, and we see the estrogen levels go up during the preovulatory phase. And the corpus luteum secretes not only estrogen, so estrogen levels stay high, but progesterone for the first time. So once the corpus luteum forms, that's where we see increasing amounts of progesterone being secreted. And eventually its levels get very, very high along with estrogen. The egg is released at ovulation, let's say on day 14, but the egg only lives for no more than 24 hours. So fertilization is going to occur, it has to occur at the time of ovulation within 24 hours. Because by the beginning of day 15, 24 hours after ovulation, the egg dies and can't be fertilized at that point. So the corpus luteum, if a pregnancy doesn't occur, dies after 14 days. So if the corpus luteum forms at ovulation at day 14, 14 days later would be day 28. That's when the corpus luteum dies. And when it dies, it no longer secretes estrogen and progesterone, and estrogen and progesterone levels plummet. Without estrogen and progesterone, the functional layer of the endometrium can no longer be maintained, and its cells start to die off, and they're shed. Blood vessels break, mix with shed endometrial cells to form the bloody discharge. And the endometrium, it sloughs off, thins all the way down to the basal cells, and then of course we're just going to repeat all these events. So I do want you to definitely be able to generate this graph showing these hormonal changes that occur during a menstrual cycle that would then repeat itself every 28 days. Now, if a female gets pregnant, things change a little bit. So recall that the window of opportunity for getting pregnant, in other words, when a girl is fertile, is actually longer than the lifespan of the egg. It's probably 3 to 5 days, because sperm could be ejaculated into the vagina a couple days before ovulation and still be living and viable in the fallopian tube when ovulation occurs. So there's probably a 3 to 5 day period around the time of ovulation during which it's possible, if a girl is having intercourse, to get pregnant. So let's assume that the ovulated egg is fertilized and the zygote forms in the fallopian tube. It develops into an embryo. The embryo eventually goes into the uterine cavity, and the embryo would implant 7 days after fertilization in the middle of the post-ovulatory phase. And the embryonic cells, as they form, secrete HCG, and HCG prevents the corpus luteum from dying, and as a result, the corpus luteum doesn't die, it lives on and continues to secrete estrogen and progesterone, so their levels don't plummet, and that maintains the thickness of the endometrium, and it doesn't slough off. And because it doesn't slough off, a female doesn't have a period. And that's why a sexually active female who skips a period probably needs to get a pregnancy detection test to see if, in fact, she's pregnant. So I'd like to talk just a little bit about the thickening of the endometrium that occurs during the preovulatory phase. So this would be the uterine wall, consisting of the perimetrium as the outer layer, the myometrium where the smooth muscle cells are found, the thick middle layer, and then finally the lining of the uterus would be the endometrium. And we're going to assume that this line right here that I've drawn is the stratum basale layer of the endometrium, which is never shed. So at the beginning of the preovulatory phase, an ovarian follicle secretes increasing amounts of estrogen. And the estrogen from the developing ovarian follicle travels to the basal cells and stimulates the basal cells to divide by mitosis. And as that occurs, the basal cells of the endometrium, when stimulated by estrogen, grow a functional layer. So now we've got the basal layer of the endometrium and a functional layer that grows out from the basal layer during the preovulatory phase, when the basal layer is stimulated by estrogen secreted by the ovarian follicle. Now, during the post-ovulatory phase, the corpus luteum is secreting estrogen and progesterone. They maintain the vitality of the functional layer cells, so they don't die. But at the end of the post-ovulatory phase, when the corpus luteum dies after a 14-day lifespan, assuming there isn't a pregnancy, then the levels of estrogen and progesterone plummet. And when that occurs, the cells of the functional layer begin to die. And as they do, they slough off in patches. So that's the beginning of menses, and the cells of the functional layer start to slough off, and as they do, blood vessels in the endometrium break, and blood spills in and mixes with the dead endometrial cells, along with heparin that prevents the blood of menstrual discharge from clotting. And this menstrual discharge then would flush out of the uterine cavity and be absorbed by a tampon placed in the vagina and changed on a regular basis. So at some point in time, over a 5-day period, the functional layer completely sloughs off all the way back to the basal layer. And that's when a preovulatory phase begins, as a follicle starts to secrete estrogen, and the functional layer would be grown again, and then as the corpus luteum dies at the end of the postovulatory phase, the functional layer is shed, and anyway, the whole process repeats itself.